Please, can you see my screen?
Yes, Edward. Loud and
Yes.
direct.
Yes.
Okay. Thank you very much. So there's the sandbox. I know by now all of you are familiar with the sandbox and how it works, how to even import data into the sandbox. Everybody is familiar with it. If you're not familiar with it, you can visit the training.digitaletafrica.org. We actually have a training sample on how to actually import something into the data and how to also use the sandbox. We have a 6 weeks training there, which you can also participate in it. And after that, you earn a certificate of your participation within that. So this is the sandbox, and this is a notebook that I've created purposely for this live session. So the first thing that normally we do is to load the packages that you'll be using for this particular things. So these are some of the default packages that we use. The first importation are default packages from Python packages. So we have the NumPy, XArray, Datetime, GeoPandas, and the Matplotlib. Then you also have the GeoPandas. Then the second one here are tools that comes with Digitalet Africa. With these particular tools, you can't get them from any other packages unless you are using the sandbox. So you have the data handling, the ban indices, the plotting, and the DAX. It actually comes with the Digitalet Africa platform. And these packages makes it easier for us to load data and also interact with the data sets that we have. So after that, the next thing is to work with define your data cube object. That's the connection. So using the data cube, then the app name. Here you can actually specify any name you want to know, just to make sure that it actually differentiates it. And this app connection is created once. So if you're going to use 20 different algorithms within this notebook, you have to create only one data connection. Then the next step is to use the DAX cluster. The DAX cluster actually makes it easier to load data quickly. In one of the sessions coming weeks, we will actually talk into details on how to use the DAX cluster and how it actually makes loading of images quickly, and also some of the disadvantages of using the DAX cluster. In the coming weeks, we will talk about those ones. But with the purpose of this, we will create a local DAX cluster. Then from the cell 4 is to define our parameters. The one that we're actually interested, the indices that we will be using is the NDVI. That's the one we will be using it. Then you also specify the product. That's the Sentinel-2 product is what we will be using. Then the area of extent, that's the lat long. Then the time range. With this particular tutorial, so I chose to use 2018. And the mean good data, that's the cloud-free data that I want. With this tutorial, I chose to use 0.50. You can actually choose to use 0.9 or even 1, depending on the area that you are having. But one is 100 cloud-free, which sometimes will be difficult to get. So sometimes having a balance of it like 0.5 is much better. Then the resolution, with this tutorial, I'm using 50 meters by 50 meters. One great thing about the data set is easy to do the downscaling and the upscaling easily. You just specify the resolution and the system will actually do the rest for you. Then the dash chunk is how many data I want to load onto the system. But with the dash chunk, we will leave it out for the next time discussion, whereby we will actually talk about it more. So the next process is to display the area of interest that I want to work with. I already chose an area in Rwanda. And the name of that's Virunga Mountains. So I just chose an area called Virunga Mountains in Rwanda. And we just want to see the vegetation index of that particular area that I chose against the rainfall data that we have. So with the latitude and long range, I just specified the centroid point of the area that we are working with. Then I apply the buffer to it. So the lat buffer and the long buffer to it. And that's what actually helped me to get this area. So we define a query object. The main reason why we define a query object is to make the system reusable. So in case I want to call another data set For instance, with this one, I'm calling Sentinel. But if assuming I want to call Landsat, I don't have to actually write everything like here. All I have to do is I'll just call the query here, just as I've called it there. Then automatically, you would it will actually load all the data sets with these parameters that I've actually specified here. Because I'm also interested in the NDVI, normally it's best to load only those areas, that's the areas of interest that we are actually after, which is the red, near infrared, and the XCL. Those are the ones that you only need, and only specifying those measurements will also make the data load very faster, because if the order comes in and they are not going to be used, they are going to be redundancy. So just to prevent this redundancy, we actually specify these measurements, the only measurements that we actually need. So in cell 7, what I did was load the ARD. So with the load ARD function, I'm able to connect to the database and load all the data sets that I'm using. Because I've actually specified the dash chunk here, that means the data sets are going to be loaded in batches. Not all of them are going to load for me based on the pixel size that I worked on. So from here, I just loaded it up. Then as you can see, this is the data sets that it was returned. That's the 22 time steps. That means 22 time step was actually gotten out of it. So if you look at it, the whole time step was actually 70 time steps for the whole year of 2018, sorry, but only 22 were filtered out. So that's why if you look at the time step here, you actually see 22 time step is filtered out. If I would have changed the mean good data to 90, probably this side also would have reduced. And if you make it 1 and don't get any images, it will be like filtering to 0 out of. That means no image was returned and the code will actually break. Then within the next, what happened was to do the cloud buffering. Cloud buffering also actually helps to actually remove these clouds and make the data actually a good data for you. So apart from getting the mean good data out of it, we also use the cloud buffering for it. Then from this area, I did the calculation of the NDVI. So here I use the calculate index, which is already an inbuilt function. Then I call the index that I wanted to work with. That's the NDVI. So calling it, and the collection was Sentinel-2, meaning it is going to, the function is going to work based on Sentinel-2 collection. Then from there, the next thing I did was, because right now I don't need the red and the near infrared, I just have to drop them because I don't need them anymore, so that it also make my work more efficient and faster. Because I use the DAX array, the data are being loaded into my memory in the form of batches. But right now, I've been able to remove most of the measurements out, leaving only the ones that I need. So right now I'll use the compute function. What the compute actually do is it will actually load everything from the DAX and now come and put it on my system memory, so that right now all the system memory will be on my on the resources that I'm using. That's the memory of the sandbox. So with the compute, I load everything inside. Then from here, what I did was I just calculated the mean in the X and Y dimension. Meaning I want to calculate the mean along the X and Y. So that means the time will stand out, then the mean will compute out of it. So from here, I was able to get the NDVI values from the system. Going down, we do a resampling, and with the resampling, I told him I want to do monthly. So I want monthly NDVI for the whole of 2018. So there's the plot of the area, Virunga. There's a plot of Virunga, the NDVI values of Virunga from January 2018 to December 2018. Actually, I can't really look a little bit, okay, so what is actually happening? But if you look at it, all the NDVI values are actually over 0. That means it has there was a vegetation throughout the year, but it varies. So this is where, if you bring in the rainfall data, it actually give you an essence of actually what is happening around the area. So the rainfall data that we have is the ERA5. It's actually of low resolution. That means it's the resolution is 31 kilometer by 31 kilometer, which is actually a very big, very big. So that's one of the downsides. It's actually have a very low resolution for the precipitation. So there's already an inbuilt tool for that. So what you do is you import the load ER5 data into the sandbox. Then you specify the variable that you are going to wear. Because the ERA5 climate data doesn't only come with precipitation. You can get wind, temperature, even snow data out of it. You have to specify the one you want to work with. And if you want to get to know more information about the ER5, please go, if you go into the sandbox, go to data sets. Once you go to data sets, you're going to see another folder called climate data. Open that climate data ER5_AWS. Open that one. Then it will let you know all the different variables available for that particular data set. So you have the precipitation, we have the wind, we have the temperature, air pressure, snow, and solar radiation. All these ones are available on the platform. And if you go below, it gives you further information on how to actually work with it. But with this tutorial that we are dealing with, we are only actually interested in the precipitation. So we specify the precipitation underscore amount underscore 1 hour accumulation. Then we would load the lat long. We've already specified the area of interest that we want to work with. We've already specified the time range. Then the reduce function, we are going to use the np.sum, and the resampling is going to be 1 month. So it's going to resample into 1 month. You can actually do a resampling of one daily, depending on how you want it. But for these tutorials, you can actually, we are using 1 month. But if you want to resample it daily, you just use and change it to 1D. That means you want daily resampling. And there's an 1 hour accumulation. So it's actually going to accumulate all the 24 hours for you in the form of a sum. But with this tutorial, we use the monthly. So you pick the month. Then once you load it up, you're going to see the precipitation values here. So you're going to see the lat long and the precipitation, the lat long. With the ER5 data, it's actually in meters. So for precipitation, it's better to convert it to millimeters. So what this function actually does here is to converting the data from meters to millimeters. Then the next one is to plot the data out. So with this side, we plot the data using the dot points. You can actually use the line whereby you make the line with 1, or you can even go for bar, depending on how you actually want to do the data. So once you plot the data, this is how the precipitation data is being accumulated for 2018 for that particular period. And below it is the NDVI value. So what you can actually do is, having these two data, you can actually start to make a further analysis on why is it that from 2018 May to 2018 July, all of a sudden there was an increase in vegetation. You can actually go and look at it from the precipitation data that between 2018 March to 2018 May, the precipitation started to rise. That means there was more rainfall that was being measured. So I think that one could also contribute to why there has been a sharp NDVI increase from May to August. So having these two data, you can actually have the feel of what is actually happening on the ground with this precipitation data, which is here. So mind you, the resolution is 31 kilometers, which is very big. So depending on the area that you are working with, if it's not that much very big, it will also give you an idea of what is actually happening within that area. So this is how to actually work with precipitation data within the sandbox. and also compare it with different areas that we have. So this is the Virunga Mountains, in which it gives us a nice vegetation curve. And also comparing it to the precipitation also gives us also a very great presentation curve. So this is how to use the two data, and it's actually very easy to work with, and you can actually load it within Africa, anywhere you can actually load it up and you can use it. Apart from the precipitation, you can also check about the temperature, the air pressure, the solar radiation, depending on the area of interest that you want to work with. You can also check about all these parameters and work with it. So you'll be happy if you can go through it and play around it, and let's see how we can actually use it in the various works that we are doing to come up with a very great solution for our works that we are having. Thank you very much. So at this point, please, is there any question that you have before you just pick additional 2 places where you know how the vegetation trend is? Just give us the latitude and the longitude. We'll just go to that side and also run a few areas and see the end results about it. But before that, any question in relation to what I just presented?
Thank you, Eddie, for that beautiful presentation. You know, you and I have been looking at these different vegetation indices for some time now. So anytime there's a presentation of vegetation indices, I am particularly interested. Hello, can you hear me, please?
Yes, man, we can hear you.
Okay, good. Looking at the 2 graphs you presented, I'm sure you are trying to also give reasons why you see a spike around June, July of 2018. Yes. And then which is the line graph, and then you are comparing that to the point graph up there, isn't it? Which talks about precipitation.
Yes.
But when I look at your plot, I see that the spatial references are 2 different things. I don't know if that is a mistake with the code or something, but it suggests to me that we are comparing 2 different areas.
Oh, okay. Yeah, thank you for the pointing. So this one uses the 6933, then 4236. That's not actually a problem. So with the spatial reference, I actually specified it at this section. All of them are actually equivalent to the 4326. So you can actually change it to 4326 here. Then run it for the whole area again. But all of them actually uses the same thing. And this area is not big, so we can run the cell for those 2 areas to get the results again. Thank you, Ben, for actually noticing the coordinate system. But the 6933 and they actually equal same areas, like very close projection systems.
Okay. So I also heard that you were asking if we could bring suggestions or give areas where we want to be tested.
Yes.
I'll give you an area, because, all right, maybe this should be out of this platform. We can look at that on a one-on-one basis. So let's go ahead.
Yeah. Okay, Ben.
Yeah.
That would be great. Yeah, we'll be happy to do that.
Okay, thank you.
I think we have some points shared by Victoria Neema. She can maybe give us more information about the area, or it's maybe her village, or it's yes, please.
Those coordinates are for the Moya area around the Moya irrigation scheme, which is I think currently the biggest paddy rice producer in Kenya. So I wanted to see how the precipitation and NDVI affect each other around that area.
Thank you so much. Edward, I've put the correct coordinates. As you know, it's a minus for the south. And that one.
Thank you, Ken. Yes, Ken, thank you very much.
Thank you, Victoria. You'll see your results shortly. And I know this one will be of interest to Stephen Corey, who's just joined us from Pula. Stephen.
Yes, yes. How are you?
Welcome, sir.
Thank you, thank you. Sorry, I'm on the road. I'm driving, but I had to make sure that I joined the meeting.
Oh, please watch the road, sir.
No problem. I'm okay.
Okay.
Okay, thank you.
Yeah, Victoria, please, am I in the correct area?
I'm waiting for it to load to see.
Yeah, it's around that area.
Yes,
Where?
it's around that area.
Oh, okay. I think the buffer is big.
It's a pretty, yeah, I think it's pretty huge.
So, yeah, let me reduce it a little.
I think this should be the range of 0.05, sir.
Okay. Zero 0.05.
That'll
Yeah,
be more
let's
reasonable.
try that. Mhm.
Yeah, I think that this is fine. We can stick to this new area. Perfect. So let me run it to finish right now so that I can see the results out of it.
Thank you,
So
Edward.
as you
And
can
now,
see,
I was also thinking of your desk, the chunks. Maybe they could be less or bigger
oh, the dash chunk.
because
Yeah,
your internet, I know it was very interesting today and yesterday.
Yes, Ken. Let me check. One great thing about the dance is you can just come here, click on the client, and you see how best is computing. If it's so, just as Ken said, we can also increase the size. So if what I'm opening right now, what the let us know whether we have to increase it more so that we can actually do the computation quickly. I think the computation is even done. Wow. Can today my internet is on it.
I think now you've upgraded to MTN.
Yeah, today the internet is not it's actually so this is actually the NDVI for that particular area. Yeah, so that's the precipitation. Interesting.
Yeah, there's a funny correlation there. And I remember in the ERI 5 we had earlier.
It's rainfall before vegetation. Then since it's a paddy land, it's under the water is regulated.
Okay.
Yeah.
Wow. That's really interesting. So I think having these two data, you can easily compare the data and just gives you an idea. So this is actually a 2018 data set that we are using. So you can actually change it to 2019 and see the end results of what is actually happening around that area. Okay. Please, any other area that you can try data? Hello, Victoria.
Oh, hello.
Yeah, so this is the results, and David actually gave you talk about it.
Oh, I think I missed that part. If he doesn't mind, could he please repeat it?
Okay, I'll start with the rainfall part. We're having from 2018, around 2018. We all understand around the equator, we have two rain seasons. That is the MAM and the October, November, December. MAM is between March, April, and May. And then we have October, November, December as well. So for the rainfall, starting from around March, that is 2018 around March, we are seeing a rise up to around May, that is March, April, May. May, we are at the peak. Then we are starting at a descent of the same, coming down up to around July. Then we're having a slowdown up to around September. Then from October again, we're having the short rains. Then it tries to, well, depending with how the conditions are, normally it starts again going down. We're coming back to, so the same trend of March, April, May, October, November, December. We normally have slight rainfalls between, it's called the just period, that is June, July, August, September. We can see the dip between in between July all the way up to in between November. But I think November is already high, up to around October. Coming down, we understand sensitivity of NDVI to rainfall. It takes a little bit longer for us to pick NDVI using optical. So from around March, it starts going up because that's the same period that we started receiving rainfall. It goes up to when the crops are fully grown. I believe rice is about is a 3-month crop, if I'm not wrong. Please, Victoria will correct me later. Up to around July, then again it starts going down. Then from October again, that is for the vegetation index. Can you please pull it a little bit up? Yeah, then from around October, then we have another rise. So the trend follows the same way. So rainfall, a small delay to allow for the vegetation to grow. Then it starts peaking, then another rain season. By this time, I think normally since to the farm until the rice is fully mature. Back to you, Edward.
Thank you, David. Thank you very much for the explanation. Victoria, please. Hello, Victoria. Yeah. Oh, okay. So these are the areas, and we'll be happy that you can try it out at your end, not only for vegetation, but even for water extent and any other areas that you are interested to use this rainfall data. We'll be happy, and we are here also to support you. So you can reach out to Ken, Joseph, and I for any support that you need, and we'll be happy to help you on that. Okay, please, any more question? Maybe any area that you would like us to work on?
Yes, thank you, Edward. I think we have Martha from NBS. She's not joining us in a minute. Martha. Maybe she's not connected. Any other question? Also, we were joined by Victor also, who disconnected at some point. Moshoshoi, will this tool be useful to you for us in Lesotho?
Yes, it will be useful. But now I'm thinking of a scenario whereby we have like 2 types of fields. The other one is rain-fed, and the other one is full-blown irrigated. How would the correlation between, will there be any misconception between the NDVI correlation and rainfall correlation?
Thank you so much, Moshoshoi. I think partially David, our colleague from RCMRD, tried to answer this one. And it was that with irrigation, you have guarantee of water all through the seasons. So it's dependent on the crop that you've grown. So like you have a controlled environment, like partially like a greenhouse. So with the rain-fed agriculture, it's pretty much predictable with the trends and the rainfall and the indices. But now with the irrigation, there's a lot like artificial conditions that it has water all through. So it depends on how the phenology of this crop is.
All right.
So for example, in Lesotho, you also grow the nice oranges like in SA?
No.
Okay.
No.
Yeah, those ones are done under irrigation, I think. Yeah, David, sir.
Sure. I just wanted to, in order to bring out what I was talking about, maybe later on, Edward can try to do a plot of the SAR data to do across. There are some indices that can be used to behave the same way as NDVI from SAR. So I believe we can try that. Then we can see its sensitivity. We can compare the sensitivity of optical and SAR when it comes to vegetation monitoring.
Thank you, David. Over to you, Edward.
Yeah, so David, I think that's a great suggestion. That's a great suggestion, and I'll be happy that we can work on that together and probably present it on maybe coming one of the live session coming. So we'll be happy that we can do that work together.
Okay.
Actually, we had planned to have Stella today, but she postponed to next week, Wednesday, which will be more useful for us and everybody. And also, Edward, if you're able to share the file on the chat or the other group, will be okay. Thank you so much.
Okay, Ken, I'll do that. Okay, thanks everyone. I'm stopping sharing. Okay, Ken, over to you.
Thank you so much, Edward, for this presentation. We also had a request by Corey last time. He was working in some fields in Nigeria. And hopefully, since now he's driving, I don't know, he can comment on the same. But we are happy to use this tool to look at that, because this was paddy fields in Jeba, in Niger State, for rice farming.
Hello, Kenneth. I was unable to continue the analysis because I was on the field, but I've now come back, so I will continue the analysis and let you know.
Thank you so much, Corey. So,
Thank you.
okay. So if there's no other question, we can connect.
Hello.
Yes, sir. Yes,
Ken,
please.
I'm sorry.
Yes, please.
I just wanted to push a coordinate to Edward.
Yes,
to
please.
check on NVI for 2020, if that is that possible?
Yes, it's possible. If you put it in the chat, you'll just.
All right.
Yeah,
I'm doing that in a second.
Thank you. Could it be Aparama forests?
Sorry. Second.
It's one of the forests that we are monitoring.
It's a mango farm.
Ah, nice.
Yeah.
Okay, so Ben, you can share it with us and we can run it.
Yeah, I'm sharing right away.
Otherwise, David, any progress from your side?
I think let me make a promise. After next week session, then I should be the next one presenting.
This will be very great news, Edward. David.
Okay, thank you.
So any question, Xavier or Moshoshoe or Martha or Victoria?
Edward, it's
hello.
Please.
Hello, Kenneth.
Ben,
Yes, Victoria, please.
You seen it?
Yes, Ben.
All right, thanks.
Yes, we had a comment from Victoria as we process this for Benjamin.
Edward, I just want to say thank you for this, for your very nice presentation, and I'm still digesting it, and I want to do some analysis also. Then I'll share if I have any challenge or any experience that is different and it can help in improving anything.
Okay, Martha.
So Xavier is sending us a reminder of this code. And also, Xavier, are you in our group in the ASIAMAD champions? I think our admin, David, is here.
Yeah, Xavier is a member. I'm not sure if he finished his self-paced, but he's a member. I just also wanted to seek clarification. Do we still have our live sessions tomorrow?
This is separate.
Okay.
Yeah.
All right.
Yes, sir. Ben, please, is this the area?
Yes. But you have to lower the 0.05. The it's so big. These
Yes.
Yeah.
You should limit it.
Should I still limit it?
Yes, Father.
Should I go again?
This should be his farm now.
Okay, so I think you are good to go.
Edward, can I see the coordinates you entered? Because it appears you are out of the farm.
Oh, okay. Ben, that's the coordinates.
So don't put minus there.
Oh, okay.
Yeah. You know, it's around the Somalia area. So just around the eastern, yeah. And the year should be 2020.
Oh, okay.
Yeah.
Okay, let's look. Ben, is that the area?
So this is the farm. Yes, that's the area.
Oh, okay.
What adjoins it at the southern portion is a forest plantation, but mainly you have the mango farm within. So that's the boundary you see.
Oh, okay.
In the center of
one.
the images. Yes, that's the mango farm.
Oh, okay.
So this looks also very interesting. Your farm is doing very well, Benjamin.
Yeah.
So at least this gives us an opportunity that you can explore any farm, and Edward will share the file with everybody. And also the best thing is he can also share with you on WhatsApp, any platform that you require. And just to summarize our lesson today is that we've had like 5 examples and interpretation. Yes.
Ken.
Yes, sir.
Before you go on, I think I brought this up for a very good reason. I got some data from the DI Africa platform for NDVI and other vegetation diseases. It's something I'm working with Edward on, okay? And with these NDVI values we are seeing, I realized that for 2020, we had a different kind of trend compared to the previous years like 2017, 2018, 2019. So in the research I'm doing, that raised some kind of flag for us to investigate further, okay? And then one of my team members decided to download the image and then do a manual kind of, or the normal way of classification we know, to try and then calculate the NDVI for the farm. And the maximum NDVI values that were obtained for this farm were different from the maximum NDVI values we were getting from the Dear Africa platform. The ones that were obtained from the standard calculation were much higher than what was obtained from the Dear Africa platform. And looking at what Edward just showed, I realized that the highest figure that you will see on the graph is about 0.65. But in that one I'm referring to, the one the team member calculated was above 0.81 and 0.7 thereabout.
Okay, so Ben, I think one thing that we can also look into maybe further on is the calculation method, because
Yes.
we are using the median and the mean and also the month accumulation. So later
Exactly.
on, we can also, with the manual one that your friend did, you can actually also pick it up, because we recently had the same issue with one of the work streams, rain trust. But you notice that the method they were using wasn't the method they gave to us. So later on, when we applied their method, we almost had the same results.
The same result. Okay.
So it would be great for us to know the manual process that he went through.
Yeah.
We just automate it here. Then
Beautiful. Beautiful.
Yeah.
So I mean, I just raised this for it to stimulate some kind of discussion amongst us. But this is something we are working on the side. So I mean, that was just by the way. Thank you.
No problem, Ben. No problem.
Yeah.
Okay.
Thank you very much, Benjamin. We appreciate
Thank
any
you.
criticism on this because it's a process where we are learning from everybody, and this information helps us to improve the results for specific end user or stakeholder. I also wanted to add that possibly with some of the data that we have, we can run the algorithm, but then if the image has a lot of clouds, there is some error. This has been noted in case of where we are looking at the water index, etc. And DE Africa has been able to develop the Sentinel-2 GeoMAD, of which Edward has presented to you or any of your colleagues, or will be featured in the next presentation or so, which gives you a better view of which I was presenting to someone in Botswana, and it really added value. So any comments that you have, it's really much welcome. Together we are making the program easy for everyone in Africa, and also to be available for everyone to make use of it and to benefit. For example, Forest Commission will be able to do much more work for the work in Ghana and beyond.